Welcome to the metrology lecture series. In the present video, we will discuss the measurement of composite errors of a gear. Let's see what is composite error. Composite error means the combined effect of all gear errors when the gear is actually working. So in the composite error, we have to consider the combined effect of all gear errors such as the pitch error, profile error, runout, etc. These all errors are considering as the combined effect. Let's see how it is checked. The gear is to be tested is made to mesh with a standard gear is called as a master gear. So here which we have to measure the gear, it is the measured with the standard gear. Then a spring force keep both the gear tightly in contact. Then as gear rotate, we measure the change in center distance between them. If the gear is perfect, center distance between the gear and the master gear remains constant. If there is any error is present, center distance between the master gear and the gear is changing. So this test we are generally calling as the rolling gear test or functional test. Let's see the basic principle. The gear under test is rolled with a master gear under spring pressure. So in the schematic you have to see here. Here gear to be tested is measured with the master gear under the spring pressure for a tight mesh. As the gear rotates, we measure the change in center distance between the two gears. So after the tight meshing, then we have to rotate the gear. Then we have to measure the center distance between the master gear and the gear to be tested. If the center distance is constant, there is the no error in the gear. If the center distance is variation, it indicates the error in the gear. So next we have to see the types of composite variations. There are the two types of composite variations. First one is the total composite variation. Second one is the tooth to tooth variation. First we have to see the total composite variation. Total composite variation is the total change in center distance during the one complete revolution. So it shows the overall accuracy of the gear. And second type of variation, that is the tooth to tooth variation. It is the change in center distance when the gear rotates by one pitch. So it shows the variation between adjacent teeth. So in general, for the tooth to tooth variation, gear is rotated through an increment of 360 divided by number of teeth. A uniform tooth to tooth variation shows profile variation, while a sudden jump, it indicates the pitch variation. Measurement of composite error is suitable for the large gears. Sometimes it also ensures proper control over tooth spacing. So composite type of checking takes care of various errors in the gear. The composite method is also very useful for checking worn gears. So let's discuss the master gears. Master gears are gears manufactured with high accuracy and are used as a reference standard for comparing the accuracy of other gears. So here master gears are using as a reference standard gear, and this gear is comparing the accuracy of the other gears. They are mainly used for determining composite errors, and moreover In the composite error method, master gear is rotated in close mesh with gear under the test. So in this regard, double flank contact as well as the single flank contact. And master gears are also used for calibrating gear checking instrument, especially used on the shop floor. So let's see the materials and properties of the master gears. So master gears are made from chromium manganese tool steel or high quality gear steel. And hardness point of view, so these master gears are hardened about to 62 HRC. And these master gears are properly stabilized to relieve internal stresses and maintain the accuracy. So in general, Parkinson gear testing machine is generally used to carry out composite gear inspection. Let's see the discussion of the Parkinson gear tester. So this is the schematic representation of the Parkinson gear tester, and this is the instrument which is used in industries. So let's discuss the briefly. So in the schematic representation, you have to observe here a standard gear. So this is the standard gear is fixed on vertical spindle. So this is the vertical spindle and it is the fixed one. So there is no movement in the standard gear. And moreover, I have to observe in the schematic gear to be tested. So this is the another gear. So this is we have to go into test. This gear to be tested is mounted on another vertical spindle and it is placed on sliding carriage. So this is the sliding carriage. So now gear is mounted on the sliding carriage and standard gear is fixed position and it is mounted on the vertical spindle. Now moreover, I have to observe in the schematic, both the gears are kept in contact by using a spring force. So here we have to applying a spring force to maintain the tight contact between the gear to be tested and the master gear. So let's see the what happens during testing. When the gears rotates together, so gear to be tested as well as the master gear, so both are rotating together, then sliding carriage moves slightly backward and frontward due to errors in the test gear. So now both of the gears is rotating together. Then if there is any movement in the sliding carriage is maybe frontward or maybe the backward. So this movement is due to the errors in the gear to be tested. If there is no errors in the gear, now this center distance between the master gear and the gear to be tested is constant if there is no error. If there is any error, mean center distance it will be changes, then it will be indicate the movement of the sliding carriage. It will go to the forward as well as the backward. So this movement of the sliding carriage is shown by the dial indicator. So it is attached to the one dial indicator. This dial indicator shows the movement of the sliding carriage of backward and frontward. These movements indicates the irregularities or errors in the gear being tested. So next we have to discuss about the how to record these results. So instead of dial, so in general we are using the electronic recorder or the chart. So this electronic record or chart, it produces a graph which has showing variation in gear accuracy during rotation. So let's see the briefly regarding the working and setup of the Parkinson gear tester. So let's see the working. So this is the figure and schematic representation of the Parkinson gear tester. So which has to be shows a gear tester used for testing of spur gears. Similar testers also available for checking the composite error of bevel, helical and the worm gears. So let's see the setup of the gear tester. The gears are mounted on two spindles, allowing them to rotate freely without noticeable clearance. And the master gear is mounted on adjustable carriage. So this adjustable is mainly for this position can be changed to suitable for the different gear sizes. It can be locked at any required position. So master gear is in fixed position, but we are mounted in the adjustable carriage for the, if any varying the size of the gear, we can be adjust the position of the master gears. The gear under test is mounted on spring loaded carriage. This ensures proper meshing with the master gear, and moreover contact force is controlled by spring pressure. So let's see the measurement arrangement. The distance between the two spindles is adjusted to match the correct center to center distance. In this regard, a scale and vernier are provided, which has to be used to measure center to center distance, and this accuracy is limited. It is the up to the 0.025 mm. When these gears, master gear as well as the gear to be tested, are in the tight contact by the spring force and rotated, then any errors in the tooth form, pitch or concentricity of pitch line, it will be cause a variation in center distance. In this regard, movements of the carriage as indicated to the dial gauge, which shows the errors in the gear under the test. So instead of dial gauge, a recorded can also be used. It produces a waveform chart or maybe circular or irregularities chart, which has to be showing the gear errors. So in general, this is the circular or rectangular charts, which has to be shows the irregularities in the gear to be tested. So the figure reproduction of few typical charts with a reduced scale and the magnified the radial errors. So in general, we have to classify these charts into the three types based on the gear quality. Let's see, the first one is the unsatisfactory. Why it is unsatisfactory mean? There are the large and uneven variations in the center to center distance. And second chart is indicating that one it is the moderate quality, because very small variations in the center to center distance. And third chart is indicating the fully satisfactory, because there are the negligible variation in the center to center distance. This Parkinson Gear Tester also having certain limitations. So first one is the size limitation. So this tester is generally suitable for gears up to 300 mm in diameter, but most commonly it is using for gears which are having the 150 mm in diameter or smaller than this diameter. And second limitation is, so this test requires very low friction system, which means the floating carriage must move freely. So very low friction it should have to move, and highly sensitive measuring system is required for accurate results. And third limitation is limited accuracy. So this tester having the limited accuracy, that is about the plus or minus 0.001 mm. And moreover, this tester cannot detect all types of errors, which means the rolling test is mainly shows the composite or combined errors. So it does not reveal any individual errors clearly. And fifth limitation is errors are not separated. So different errors such as the profile error, pitch error, helix error, tooth thickness error, these are all errors are mixed together and cannot be identified separately. A last limitation is depends on master gear accuracy. So measurement accuracy is depends on the quality of the master gear. Any error in the master gear which will be effects on the results. So this is the discussion of the Parkinson gear tester, and thank you.